NF3 positive, NR3 positive, and after that NS3 positive. Hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss a very important term of organic chemistry, that is inductive effect. Basically this inductive effect we study in a separate topic, that is general organic chemistry. For that we have already covered up the covalent bond fission, or you can say cleavage, homolytic cleavage, heterolytic cleavage, that is being discussed in the previous video. So in this video, I am going to discuss in quite detail regarding this inductive effect. So this is the phenomena in which a carbon chain gets some positive or negative charge. So if you visualize over here, CS3, CS2, 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 let's say some group X is being attached. Another example, CS3, CS2, CS2, CS2 and Y. If we are attached some atom or group of atoms such as X and Y on these carbon chain, and this carbon chain contains a partial positive charge or partial negative charge. If some charge is being generated throughout sorry so if some charge is being generated throughout this ring carbon chain due to some presence of some you can say atom or group of atom, and that effect is being termed as inductive effect. The phenomena is induction and the whole effect is being termed as inductive effect. So this effect, it is a permanent effect. So basic character of this effect is that it is a permanent effect. So this effect is actually present within a compound or within a molecule. So if there is some compound is there and having some group, some electronegative group, some electropositive group attached to this carbon chain, so this type of effect is being present in that compound. So it doesn't need any outside force or outside reagent to show this type of effect. It is a permanent effect. It will always exist within a molecule. And the second term that is very important regarding this is it is a distance dependent effect. This effect is distance dependent. So if you visualize over here, if this is our some group X or Y, they are attached on this. So if this carbon which is directly attached to this X atom or X group, so it will exert some partial positive charge. So this group, it is far from this, so it will have some lower charge than this, and this group which is much far than this will exert a lesser positive or negative charge. So that's why we can say that this group or this inductive effect is a you can say permanent effect, and it is also a distance dependent effect. As far we move from that atom or group, this effect diminished. So what is the sole reason why we are seeing such effect? That is the electronegativity. Electronegativity is the sole reason why we are getting such type of effect. So if you visualize over here, let's say this X atom, it is more electronegative. It is more electronegative than this. We will see this type of effect. It will exert some partial negative charge and it will exist a partial positive charge. In the same way, if this atom is more electropositive, or you can say less electronegative, in term of electronegative, if it is higher electronegative and is lesser electronegative than carbon atom to which it is being attached, so it will have partial positive charge and it will exert a partial negative charge. So the whole phenomena is being totally dependent on the electronegativity. So this is not a, like you can say, some exact value are there. So this effect is, you can say, are having some reference that, like, see, we have to take some reference, like in electronegativity, we take like fluorine, CF is -4, then -3 oxygen. So because it is based on electronegativity, that's why this effect is also a reference based effect. This is a reference based effect, and the reference which we are going to take over will be the carbon hydrogen bond. The reference which we are going to take over will be the carbon hydrogen bond. So those atoms which are having higher electronegativity than hydrogen, they will be termed as, showing will be minus I effect, and those group which are having lower electronegativity than the hydrogen, they are going to show the plus I effect. So this is the CH bond is our reference. CH bond is reference over here. So one more important thing we are going to see over here, how this effect works. How this effect works. So if this is, take an example over here. Let's say fluorine. We are taking fluorine atom over here, and most of you are aware that fluorine is the most electronegative atom, and it is going to pull the electron pair which is present between carbon and fluorine. This electron pair will be pulled by this fluorine, and due to this pulling of this fluorine this electron pair towards fluorine, so it is going to exert some partial negative charge. It is going to exert some partial negative charge. So if you see over here that this carbon is going to have partial positive charge. This carbon is going to have partial positive charge. So this now this carbon, it needs some electron. It needs some electron because its electron pair is being shifted by this fluorine. So what it will do? It will take the electron pair, this electron pair towards itself. So that's why it will have some partial negative charge. So it will have comparatively lesser positive charge than this partial positive charge, which is being represented like this. So the same way, the same phenomena will be shown by this carbon, and this phenomena is being shown up to only 4 carbon. This phenomena is being shown up to 4 carbon only. This phenomena we are going to see up to 4 carbon only. This inductive effect is being, you can say, measurable experimentally. If we want to measure this value, so up to 4 carbon only we can measure this inductive effect value. After that, it is being that much diminished that we cannot calculate that value. So another is like if we are having some atom or group that are more you can say, positive than this, the electronegativity is being, carbon electronegativity is higher than those group. So those such type of groups, what they are going to do, they will donate the electron pair. Like if we are having CS3, this group, if you see, it is already having some electron pair. This CS2 negative, it is already having some electron pair in itself. So what it will do, it will not attract the lone pair, so it don't need some electron. So what it will do, it will donate some electron. What it is going to do, it will donate an electron to this, it will donate its electron to this carbon. So that's why over here, this will also donate electron pair to this, and this will also donate electron pair. So partial negative charge at this, a partial negative charge partial negative charge and partial negative charge. So this is the inductive effect. So these are the two type of inductive effect I have shown you. So one is the minus I effect and another is plus I effect. So those both are on the reference of carbon hydrogen bond. So if we want to know that which atom is going to give the electron pairs toward this carbon chain and which is going to pull the electron pair towards itself. So the important thing is that electron pair pulling will be within this range only. It cannot exceed this range because it is electron pair. Either this can take electron pair toward this side or toward this side. So this will be only the movement will be within the atom only, within the two atom only. So now I will show you these two series various atom in a higher order to lower order. We are going to show that plus I series, how this plus I series is being written out. So first is like NF3 positive. The first atom is NF3 positive. And after NF3 positive, we are having NR3 positive. NF3 positive, NR3 positive, and after that NS3 positive. If they are being linked to some carbon chain, they are going to show the minus I effect. They are going to show the minus I effect. They are going to show the minus I effect. NF3, NR3, NS3, NO2, Cn. NO2 and then Cn. NO2 and then Cn and COOH. So these are NF3 positive, NR3 positive, NS3 positive, NO2, Cn, COH. You need to learn these because if you don't know these, so how you cannot compare, because sometimes we are going to get some comparable type of question also which is going to have a higher inductive effect and which is showing the lower inductive effect. So that's why we need to remember this series. And after that, fluorine, chlorine, bromine and iodine. After this we are going to have fluorine, chlorine, bromine and iodine. After this we are going to have fluorine, chlorine, bromine, iodine, and after that OR, OH, NS2. OR, OH and NS2. Sorry. Fluorine, chlorine, bromine, iodine, OR, OH, NS2. OR, OH, NS2. After that, alkene, phenyl, alkyne, phenyl. After that, alkyne, phenyl, ethene, or you can say alkene and hydrogen. And after that, hydrogen. So this is a trick because it is like how to remember these. So I will just tell you the trick also. You can start from this NF3. So you can learn by that, by a simple trick of if you know the Bollywood stars, then you can say that na Farhan, na Ritik, na Himesh, na Farhan, na Ritik, na Himesh, na Ompuri. So these are like NF3 positive, NR3 positive, NS3 positive and NO2 positive. Na Farhan, na Ritik, na Himesh, na Ompuri. CN means kabhi nahaye. CN means kabhi nahaye. कभी नहाए COH में, एसिड में, कभी नहाए एसिड में. क्लियर? ना फरहान, ना ऋतिक, ना हिमेश, ना ओमपुरी कभी नहाए एसिड में. So this trick you can learn from here. This upper line, the first line. So this is the highest minus I effect it is going to show compared to this in this 1, 2, 3, 4, 5, 6. ना फरहान, ना ऋतिक, ना हिमेश, ना ओमपुरी कभी नहाए एसिड में. So this is the one series. After that, this acid we are going to come on to is halogen. So these are all halogen. So we can say halogen. Now after that we can say halogen, or after that we can say halogen or alcohol. Halogen or, this is Hindi, or and alcohol. हैलोजन और अल्कोहल फिर एल्कीन है, फिर एल्कीन है. दिस वन इज गोइंग टू बी फिर एल्कीन है. हैलोजन और अल्कोहल नहीं एल्काइन, फिर एल्कीन है. So in this way you can learn this trick. Clear? ना फरहान, ना ऋतिक, ना हिमेश, ना ओमपुरी कभी नहाए एसिड में. This is a very simple and the rhythmic trick. Now also this fluorine, chlorine, bromine, iodine, halogen और अल्कोहल नहीं है एल्काइन. So it is very simple thing. So that halogen और अल्कोहल नहीं है एल्काइन, नहीं है एल्काइन. हैलोजन और अल्कोहल नहीं है एल्काइन. एंड आफ्टर दैट वी कैन से फिर क्या है, फिर एल्कीन है. एल्काइन नहीं है तो क्या है, फिर एल्कीन है. सो दिस इज लाइक फॉर माइनस आई इफेक्ट. आई हैव जस्ट समराइज दिस होल ट्रिक इनटू दिस माइनस आई ट्रिक. ना फरहान, ना ऋतिक, ना हिमेश, ना ओमपुरी कभी नहाए एसिड में. हैलोजन और अल्कोहल नहीं है एल्काइन, फिर क्या है, फिर एल्कीन है. So this is the very easiest trick to remember minus I effect. So again I am just showing you this thing. This is a minus I effect series. In this I have shown you NF3, NR3, NS3, NO2, CN and COH. ना फरहान, ना ऋतिक, ना हिमेश, ना ओमपुरी कभी नहाए एसिड में. After that halogen और alcohol, fluorine, chlorine, bromine और iodine, these are halogen और alcohol नहीं alkyne. ये क्या है, एल्काइन नहीं है. फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन और नहीं है एल्काइन, फिर क्या है, फिर एल्कीन है. सो दिस इज द ट्रिक फॉर माइनस आई इफेक्ट. दिस इज द ट्रिक फॉर माइनस आई इफेक्ट. सो नाउ वी आर गोइंग टू ट्राई फॉर द प्लस आई इफेक्ट. नाउ वी आर गोइंग टू ट्राई फॉर द प्लस आई इफेक्ट. For plus I effect, again we will be trying to first I will write these atoms, these groups for which we are going to see the plus I effect. Then I will just try to give a trick also to remember these all you can say plus I effect. CH3 negative, NH2 negative, OH negative, sorry, CH2 negative, CH2 negative, NH negative, O negative, and after that we can say COO negative, COO negative, and after that we are going to have tertiary methyl. Tertiary methyl. After that we will have secondary group. After that we will have like this. This is quaternary, 1, 2, 3 degree. This is 1, 2 degree, 3 degree, 2 degree. Okay, sorry, yeah. This is going to be 1 degree now, and after 1 degree we are going to have simple CH3, that is methyl, and after that we will have TDH. After this we will have T. Okay. T D H. So these are not that much difficult. You need any trick to learn these, because this is carbon, nitrogen, oxygen. Carbon, nitrogen, oxygen, negative carbon, negative nitrogen, negative oxygen, then acid. Or you can also learn this trick by कह दो नहीं है ऑक्सीजन को, कह दो नहीं है ऑक्सीजन को, कह दो नहीं है ऑक्सीजन को. दिस इज कह दो. ओके, कह दो नहीं है ऑक्सीजन को, ऑक्सीजन को CO नेगेटिव, कह दो नहीं है ऑक्सीजन को 3,2,1 मिथाइल. ऑक्सीजन को बताना है कि नहीं है, ऑक्सीजन को बताना है, क्या बताना है, 3,2,1, 3 डिग्री, 2 डिग्री, 1 डिग्री मिथाइल, 3,2,1 मिथाइल. ऑक्सीजन को क्या बताना है, 3,2,1 नहीं है, क्या है, TDH. क्या नहीं है वो, 3 डिग्री, 2 डिग्री, 1 डिग्री मिथाइल क्या है वो, TDH नहीं है. These are the different isotope of hydrogen. So this is the series through which we can also see the plus I effect. By this series we can also see the plus I effect. So if you remember this trick for plus I and minus I, so you can very easily tell or different various questions in which we are going to see the comparison, that which one is showing the minus I effect, the decreasing minus I effect. So all those questions can be solved out if you know this simple 2 slides which I have shown you over here. So generally in exam we are going to see the comparable question only. So like compare the inductive effect of this to this. So if you know basically this plus I series and sorry minus I series and the plus I series, I have given you the both of these series, and they are like tricks also is being given. So if you remember these tricks, so it will be very helpful for you to solve all the question based on the inductive effect. That's all for today. Thank you.